Welcome everyone. I'm going to make JavaScript object-oriented programming with inheritance as easy as I possibly can. I'm going to break it down real easy for you so you can get an understanding. So we'll say class animals, because what we want to do is create a class that is just for all animals. And to make it easy, we'll have a name and we'll have a breed. That's all we're going to have. Inside, we'll say this dot name equals name and this dot breed equals breed. So what we've done here is we've created a blueprint, basically a class called animals. Inside, the data that animals will have is name and breed. Now we're going to call a method. We're going to create, it looks just like a function. It just doesn't say the word function, but we're going to call a method that we can call on objects that we have instantiated. So we are going to say, we can do intro, and intro will have a console.log. We are going to do a template literal just to keep things fancy. We'll say this dot name is a, and we'll end it with this dot breed. That way it'd be like whatever the name is a whatever the breed is. And that's all we'll do for now, because this will get you the idea of what we need to look for. So we can say birds. We will do class birds. And birds, sorry, not a capital. We're class birds will extends animals. So essentially all we're saying is the birds are going to have a name and a breed. That makes sense. And even if we did something like this where we said eating, because all animals are going to eat, so we can just console.log is eating some food. Because all animals are going to eat. So we know that birds can easily and happily extend from animals because that's how it works in the world. From there, we can create a constructor. And this constructor will have, let's see, what do we want? We're going to have a name, and we'll have a breed, and we have name, breed, and we're going to have flying. From there, we can come down here and call super, because we're going to be pulling from this information, and super is the word that is the keyword they use to pull that information. So because we already have name and breed set, we can just say, hey, name and breed. And the only thing we have to add to that is we have to, I have to put that inside of it, sorry. Copy that. Whoops. Used curly brackets instead of, there we go. Problem solved. Instead of the normal ones. So now we have constructor with the correct, nice, round little parentheses there. And the curly brackets with super inside of it. Once we do that, the only thing we have to do is this dot flying equals flying. And now we can create a method and we can say fly. Within fly, we can say if flying, if fly is, if flying, as long as that's true, then we can say console.log and do, it's template literal, do this dot name, we'll just do this dot breed, this dot name, we'll do this dot name is flying because it is a, and we will do this dot breed, Now, of course, if it's not going to be flying, then we want to have an else statement where we'll say, we'll copy this, put it inside of our else, and say this dot name is not flying. It's not flying. So now we've created animals. We've created this blueprint with the data of name and breed. And we created two methods that we can call on it. We come down here. We have a class, basically a blueprint that's extending from animals because every bird is going to at least eat, right? And we put in flying as an optional thing for birds because, chickens aren't going to fly. So we can say const, and we'll do bird1 equals new birds. Inside of there, we can have a name, and it actually tells you right there. Isn't that nice? So we can actually go, we'll say Spiro, and it'll be a crow. I think that's what that is. I don't know. And flying will be true because that can fly. Now we'll come down here and we'll go const chicken1 equals new birds, and we'll say cluckers Stupid. And it is a chicken. And false, because chickens can't fly. For as far as I know, they're not flying. So we can do bird1 dot fly. If we run that code, it'll say if flying. Oh, sorry. We forgot. Stop flying. If this stop flying, Spiro is flying because it is a crow. Awesome. If that's not a crow, I'm sure someone's going to call me out on that, but that's okay. So we'll come down here and go chicken1 dot fly. And when we do that, we take another look, and it's not flying because it's a chicken. So Cluckers is not flying where Spiro is flying. The cool thing is that we can actually do, we'll come above and we'll say bird1 dot intro, and we have access to that because we have extended from animals. So basically we created this sort of generic type class that other things can pull from. It'd be like, your main Play-Doh cup, and then you pull from it and you actually create something. So yes, you used the Play-Doh, but now you've created something else with that Play-Doh, and you can put it back, but it uses that same information. So we have animal right here, which is just a name and a breed. That's very generic for animals with very generic things. It can do, an introduction, and you can eat, and there you go. Then we created another class called birds, and it extends that because that's very generic for animals. And we want to say, hey, birds fly, but not all birds fly. Some animals do fly, but not all animals fly. So let's figure that out. So we can have a constructor with name breed, and we added a new property called flying. We can use the super keyword here because we're using this, and we've already made a constructor with that information set, this.name, this.breed. And we can just add one more property below saying this.flying equals flying. So when we go to look at, hey, we call this method, which is fly, and says this.flying, as long as this.flying is true on that animal, then it'll fly because it is this breed. Otherwise, it won't fly because it's this breed. So all we did was create a very simple class, put in the little bit of data, a couple of very simple methods, very generic, and we pulled from this generic class and made it a little more specialized. So yeah, every bird's going to eat, and they can say hello, they do their introduction, right? And they're going to have a breed, but not every bird can fly. So we pulled from that information, we put it into birds, and we did something more special with it. And that is the key foundational understanding of class inheritance and object-oriented programming. I know it might seem a little confusing at first, but I'm telling you, once you play around with it, you could just recreate this once or twice, and you'll start to get a feel for it. You could do, you could even do adventurers, and then have adventurers who have names and levels and a job, right? And then you could have, you could start pulling types. So you could have wizards and rogues and hunters. I'm a nerd, so there you go. And so there you go. So now you have learned and hopefully have a stronger foundational understanding of inheritance. All we did was create a second class that extended this one. So we basically just said, hey, we want all that information to be accessible inside of birds, but we also want to see if they can fly. And there you go. So I hope this video helped you. If it did, leave a like and subscribe. I thank you for swinging by. I hope you all have an awesome day.